Okay, we're back. Okay, hope everybody had a good weekend. A couple things happening this week. I did change the website slightly because I was originally going to give the homework on Friday, but I figured I'd go ahead and wait because we weren't done with the lesson anyway. So you have it here. It's going to be due Wednesday. Okay. Tomorrow we're going to have a quiz, and I really don't even want to say it's a quiz. Let's say it's more of an in-class assignment, just another daily grade that I'm going to go ahead and take. But it'll give you a little practice with cumulative frequency. Okay. So let's say exit ticket is due. We're going to be doing that tomorrow in class. Then we're going to have homework on Wednesday. What's happening on Thursday? Okay, we're going to have the test. So frequency in general, frequency tables, histograms, box and whisker plots, mean, median, and mode, cumulative frequency. Okay, all that's fair game for the test. And then Friday, more than likely, will be a review, reteach, and hopefully we'll be able to continue standard deviation, which I'm planning to start tomorrow. And then we'll just continue as far as we can. The only other thing this week, Friday, the focus activities are going to be due. Now, you're only going to have 3 in the first set. We did that one last week that was the full page over quadratics. We have this second one here that's going to review you on, my baby. It's going to review you on logarithms, and you'll get another one. I believe the next one will be on Wednesday when you get your third and final one. Now, they're due Friday. If you want to turn them in early, you are more than welcome to do so. Also, talking about turning things in, let's see here. Math studies. Okay, so hopefully if you are absent, you're visiting the website, notes are there, videos are there, everything you need. Please, take a look at that prior to coming in for tutorials. I'd still like you to come in for tutorials, but if you go ahead and scroll all the way down to the first week, this is one of the documents I passed out on Friday, the Math Studies Planning Guide. This is due a week from tomorrow because we have a 3-day weekend coming up, so on Tuesday of next week. Remember, at any time, you can go ahead and change your topic, but I do want to go ahead and get you to think about what you might create your project on. Okay, and maybe you'll even start to think about what kind of data. Am I going to collect it myself? Has somebody already collected the data for me? Am I going to cite an online source? Whatever the case may be. Okay, so you can already turn them in. I already had one person turn them in just a few moments ago. If you feel you're ready and you don't want to wait until Tuesday, perfect. If you feel you need that time, okay, a long 3-day weekend to help you out, perfect. Okay, whatever you'd like to do. The only other thing, please make sure when we do turn in homework, you're turning in a hard copy. Don't go ahead and submit it digitally to the website. Don't worry about doing that. Just go ahead and give me the hard copy. Okay. I think that's all I got, unless anybody has any questions. Okay. Well, if everybody's ready, we'll go ahead and log on. It's a log joke. All right. Hopefully you'll remember logarithms. They won't be too difficult. Hopefully nobody's going to be stumped by these. Stumped logs. Come on. It's a log joke. Okay. You know what? I'll tell you what. I'll keep going. Okay. So, in a word, if we could describe a logarithm in one word, can anybody tell me what they believe it would be? Could be confusing. Okay. But the word I'm thinking of is either going to begin with an E or a P. Okay. So let me give you an expression maybe to jump start it. If we had a logarithmic expression, let's say log base 5 of 25. What's the value of this log? It's not 5. It is 2. Okay, he's absolutely right. Joey's good. Okay, the value of this logarithmic expression is going to be 2 because this is equivalent to saying 5 squared equals 25. When you're dealing with an exponential or a log statement, you got 3 parts to it. You have the base, you've got the power, and what's inside the logarithm, we refer to that as the argument. So that's really what a log is. If you could describe it in one word, it's a power. It's an exponent. It's the power you place on the base in order to get the argument. Okay, so if I were to give you another one like this, how about log base 3 of 81? Okay, so think 3 to what power would give me 81? Was it? No, 3 cubed is 27. Okay, 4. There we go. That's exactly right. Now, we've already been provided a couple of logarithmic definitions here. We know log base 3 of p, whatever p is going to equal 6. And we know that log base 3 of q is equal to 7. Well, you may or may not remember from Algebra 2, you dealt with some properties of logarithms. You had a power, an addition, a subtraction property. So I thought I went ahead and just have these written up here for you in case you don't remember. Okay, but this is showing the equivalency going from a logarithm to an exponential because they are inverses of each other. So let's say inside the argument, you have a product of 2 or more terms. Okay, you can separate that product using what? Addition. Each term gets its own log base a. So if you're multiplying, you can go ahead and break them apart through addition. If you are dividing terms, okay, you can break those apart using what? Subtraction. This is our quotient rule. Okay. Now, whatever the numerator is, that's always the first one that's written. You always want to go in order. And then, of course, we have our power rule. Log base a of b to the n. So if your term has a power on it, you can pull that to the front and say n times log base a of b. Do those seem remotely familiar? Okay, kind of, sort of. It's probably been a while since you've seen those. Okay, I'll go ahead and leave those up there for a few more seconds so you can copy them. Anybody have any questions while you're doing that about the upcoming drills? Remember, what kind of drill do we have tomorrow? We have a fire drill during first period. Okay, so hopefully your teachers have told you in that particular room where to go. If we had a fire drill in here, what would we do? Okay, leave your stuff, of course. We're going to go down the stairs, past the nurse's office, out the door to the sidewalk. But then when we hit the sidewalk, we're going to walk over to the east parking lot where the band practices after school. And then, of course, come find me because I'll get on my app, Navigate Prepared. I'll go ahead and take roll because we're going to get separated. Okay. What's happening on Wednesday? Okay, during fourth period, you got the lockout, so that's going to be business as usual. Okay, but during seventh period, that's going to be the lockdown. So should we have one in here, we're going to group right around where Lucas is. We want to be about midway between the doors, definitely away from them. Windows are going to be shut. We're going to be silent. Okay, so if you have any questions on that, please let me know. Okay, has everybody had a chance to copy this down? Okay, all right, well, let's take a look at this right here. Now, according to this problem, the maximum number of marks is 7. So that means I could get up to 7 points for this problem. There were a couple of things, we talked about the other day. With 90 marks and 90 minutes for the paper exams, it could kind of give you an idea of how much maximum time you would spend on this particular problem. So I would probably go ahead and spend at most 7 minutes. Hopefully for one like this, it's not going to take the entire 7 minutes. But also, what's another good rule of thumb when it comes to the marks? Yeah, that could also give you an idea of how many steps you could provide. Okay, subtract the number of marks by 1, whatever you have there, that's going to be a good number of steps to show as far as justification. Because remember, they won't look at your work unless your answer is wrong. Then they'll go back to your work and maybe they can give you error carried forward. They can go ahead and give you some kind of partial credit, whatever the case is. All right, so let's see. Log base 3 of p squared. Okay. Well, do you feel any of those rules that I just reminded you of could be useful here? There's one thing on this expression that I'm focused in on. Okay, so he's absolutely right. So in this case, n is 2. So I could rewrite this as 2 times the log base 3 of p, right? And one thing I've always do, a lot of times you'll see the argument isn't always put in parentheses. I like to go ahead and do that just so I can tell exactly what I'm writing. Okay, but this works out nicely because don't we already know the value of log base 3 of p? It is 6. So this is really just 2 times 6, which is 12. There we go. And then there will be a part of your test, probably down in the bottom right corner, where you'll go ahead and put your answers. It's almost like a fill in the blank. Okay. All right, well, let's take a look at B. Find the log base 3 of p minus q. Okay, so it looks like we are dividing. What do we do if we're dividing terms in an argument? We subtract them. So is it going to be p minus q or q minus p? Okay, so p minus q, right? So log base 3 of p minus log base 3 of q. We always take the numerator minus the denominator. So we already know that one is 6 minus, we know that one is what? 7. So the value of this expression should be what? Negative 1. There we go. Is it starting to come back to you? Been a while? Okay. But the rules are very easy, and the nice thing about these rules, they are reversible. In fact, they're very much related to the exponential rules that you looked at in Algebra 2 as well. Okay. Log base 3 of 9p. All right, so it looks like I'm multiplying. How do I break apart a product? Okay, what's that? We're going to add them. So I'm going to separate them according to the terms. So log base 3 of 9 plus log base 3 of p. Now, we are already provided log base 3 of p. We were told that was 6. So I'm going to add 6. What's log base 3 of 9? 2. 3 squared is 9. Remember, a logarithm is simply a power. So what should I be getting for c? 8. There you go. Oh. Okay. Television had a seizure for a second, but that's okay. All right. Okay, so any problems with the logarithms? Questions? Okay, their bark is worse than their bite? Log, it's a tree joke. Okay. Hey, you know what? If you're stuck, stick with it. It's going to be good. Maybe I should branch out into some other material. Wow, we barely made it to the third week before somebody went, oh. Okay. All right, well, hang on to these. You now have 2. I'll give you the third and final one for this set on Wednesday. We'll turn them in Friday or before if you want to. And then, probably next week we'll begin the next set again. So since we're still in the same 6 weeks, the second set will begin with 4 and then however far I'm able to get. Okay. So let's go ahead and wrap up what we've been discussing recently. Okay, we've been talking about cumulative frequency. All right. So cumulative frequency is the sum of the frequencies up to and including a certain event. Okay, so given the table, people are finding that pretty easily. One of the things we did on Friday before you guys took off, we went ahead and found these percentiles. So really, when you create a cumulative frequency curve and you look for a certain percentile, you're looking for the one element in the set of data that represents a certain percentage. Okay, like for example, this here, remember, this was based on the original problem in the set of notes that had 50 elements in it. If you go all the way back to the very front page of this set of notes. Okay, so like here, I created a cumulative frequency graph based on the class interval table that we had at the bottom of that first page. So like A wanted me to find the 75th percentile. Well, why am I multiplying the 0.75 times 50? Where'd the 50 come from? Remember, that was the number of terms in the set, right? Okay, so I got 37.5. So we're looking at this with the color red. I located where I believe 37.5 to be, and I came down here, and we ultimately got 5.4. Now remember, the data was representing lengths of different rod lengths. Okay, I think it was in meters if I'm not too much mistaken. But what this means is, okay, if I were to go back here, if I took all these elements, if I put them in order from the smallest all the way to the largest, and then I went ahead and found that 5.4, every bit of data from 5.4 below it, that would represent 75% of the data. Okay, it's a great way to group it according to whatever percents you want. You could even group it according to quartiles, like we did on the box and whisker plots. And then I think the last thing we did on Friday was to go ahead and start talking about mean, median, and mode. Okay, does anybody have any questions on those? Okay, well, let's go ahead and look at our next example here. We have group discrete data. The following distribution shows the contents of 25 match boxes. Now remember, the frequency is simply the number of times that particular element is going to show up in the set. They're saying there's 25, so if I add all these up, 2 plus 4 plus 7 plus 8 plus 3 plus 1, that should give me 25 total, right? Okay. Now, here it's just given to me as a frequency table. I could actually generate the data if I wanted. How many 47s are there? There are 2. So I would say 47, 47, okay. Then there are 4 48s. And then I could say 48, 48, 48, 48. And then how many 49s? 7. And then I could keep going, right? So if it's not a very large set of data, maybe that's something that you want to go ahead and do. But I'm going to show you some tricks where you don't actually have to do that. Okay. Well, mean, median, and mode. I would say let's go ahead and start with the easiest of the 3. Okay. I start with mode. Which one appears the most often? Okay. All right. Well, you immediately said 50 because it has a frequency of 8, the highest frequency. Okay. So I'm going to go ahead and say my mode is going to be 50. Okay. That's easy enough. Now let's go ahead and move on to mean. All right. But how do I find the average or the mean of something? Okay. So we take the sum total of all my elements and then we divide by the total number of elements, right? Okay. Well, I already know we have 25 elements. So when I'm talking about the mean here, okay, I'm definitely going to go ahead and divide by 25. All right. But how am I going to go ahead and get the sum total if all I have is the frequency table? Yeah, there you go. Like, for example, there are 2 47s, right? So 47 times 2 would be 94. So I want to multiply each element by its frequency, and then I can take the grand total of that. That would be the sum total of all the elements. If I actually were to take 47 plus 47 plus 48 plus 48 plus 48 plus 48, and so on. Okay? So somebody help me out here. 48 times 4. 192. 49 times 7. 343. That's all right. I heard some different numbers there. That's okay. 50 times 8. 400. Then I got 51 times 3. 153. And then 53 times 1. Well, that's 53. Oh, did I mess up? No. Why'd you say 62?
It's 3 times 1, which is just 53, but I was attempting to be funny. And
Oh,
yeah.
that's okay. I think when we're trying to be funny, leave it to a professional. Oh, that made you laugh more than any. Wow. Okay. Jeez. So somebody help me out. What's the sum total of all my elements? It is 1235. There we go. 1235. So I'm going to take the grand total of all my elements, 1235. I'm dividing it by the total number of elements. And what are we getting? 49.4. Perfect. There we go. Perfect. Anybody having trouble understanding where I got a value from, what I did, anything? Okay. Well, what's the only measure of central tendency that's remaining? The what? Median. There we go. The median. Okay, now, like I said, you could go ahead and list out the entire set of 25. It wouldn't be too difficult to do, but what if you do have a set of 50 or 100? You don't want to go ahead and do that. There's a faster way, and you can actually use the idea of cumulative frequency to help you out. How many total items are there? 25. So what's half of 25? By decimal, it's 12.5, right? So that means I'd be looking for the 13th term. If I were to go ahead and list this data from smallest to greatest, okay, I'd have the 13th term in the middle, and then I'd have 12 terms above, and I'd have 12 terms below, right? So I'm looking for a specific term number. Well, start with the first frequency because they're already in order, and just start adding them up. Okay, what's 2 plus 4? 6. 6 plus 7. 13. You see how I'm creating the cumulative frequency? Okay, but remember, I'm looking for the 13th term. which is now found here. Okay. Because if I take all the terms going through the number of elements, the frequency, by the time I get to 48, I know that 47, 48, and it's going to be 49, there are already 13 total terms. So finding the term number that I'm looking for, I can just stop right there. I know the median has to be 49. Does everybody see how I did that? Everybody okay? Well, like I said, if you feel more comfortable actually listing out the numbers, please feel free to go ahead and do so. Okay. All right. And I'm not really paying much attention to the formula because we already know how to go ahead and find, the mean. But mathematically, that sigma right there, what does that tell you? That's the summation. There we go. All right. Good. Okay. Well, let's go ahead and look at this one. Grouped continuous data. And actually, I think this should be grouped discrete because we don't have any decimal values. But anyway, find the mean and the modal class for the following distribution. Okay. Now, even though it says modal class, it's still the same idea. The mode is the value that occurs the most frequently, correct? So the modal class is the one interval, okay, whichever of these has the largest number of elements in that interval. So what are you looking at? 6 to 10. There you go. So I know it's in the modal class 6 to 10. Would I actually be able to tell what the actual mode is? No. In this case, no, because I don't see the what. I don't have the actual data. I mean, for example, I know there are 7 values that should be between 1 and 5. Maybe they're all 1 or 2s, maybe they're all 4s and 5s. See, I have no idea. But this brings up a good point, and it's good practice for the test on Thursday. Let's say I've got data broken into class intervals like this, but I want to know the mean. What did we use the other day in order to help us find that? You got to use the midpoint. Okay. If we don't know what the data is, we're always going to use the midpoint. So what's halfway between 1 and 5? 3. So the midpoint's 3. Okay. Would everybody agree? Okay. And then we'll do the same thing here between 6 and 10, 8 and 11 and 15, 13, 16, 20, 18, and 21, 25, 23. And you'll notice they've already got a column over here. I just wrote it over there because I'm so accustomed to doing that, writing out the midpoint, but I'll just copy these. 3, 8, 13, 18, and 23. Okay. So now I've got the midpoint. Well, now it says I need to multiply the frequency times that midpoint. So 7 times 3 would give me 21. 12 times 8, 96. 10 times 13, 130. 10 times 18, 180. And then 11 times 23, 253. Okay, so if you're looking for the average of data that's been divided by class intervals, you got to take the midpoint of those class intervals, multiply each of them by the frequency, and now what's my grand total for all those? I got 680. So now what do I do with that 680? Divided by 50. Now where'd you get the 50? There you go. Remember, the frequency is the total number of elements. So there should be 50 total in this set. So 680 divided by 50. Somebody help me out. What'd you get? I got 13.6. Okay, what do you think? Yes. Oh, we'll do that in just a second. Mm-hmm. I think after that, it just goes straight into the cumulative frequency, but we'll still go ahead and find the median. Go ahead and get you practice on that. Now, it does have this question right here. It says, is the mean in this set of data a true mean or just an estimate? It's going to be just an estimate. Why is it not the true mean? Because we don't have the exact data. Okay. Now, I showed you this the other day, both finding it the normal way and then, of course, using the midpoint. How close were they? They were really close. I mean, it should be a really good estimation of what the mean is. In fact, remember the rule, the smaller your class intervals, the more approximate your data is going to be, or your analysis, I should say, is going to be. All right. So I'm glad Stephanie brought that up. Let's go ahead and find the median. Okay. So think about what we did a few moments ago in that previous set. Okay. Try to figure out, because you don't want to list out all 50 of these, whatever the numbers are. Okay. And we're not going to be able to give the exact one. All we can do is give the class interval it belongs to. Okay. So that's really important to realize. So where is that going to be? Don't say it out loud. All right. So let me go ahead and catch up, see with what you guys got. So we got 50 terms. So the median would be what term number? 25. That's half of it, right? So I'm looking for the 25th term. Everybody's okay? So I'm going to go ahead and put 25th. Okay. So I'm going to start with cumulative frequency. I'll just go ahead and put it right here. So I start with the first 7. So going all the way from the number of elements 1 to 10, I should have how many? Okay, 19. So there's no possible way that the median could exist in either one of those. So now I'm going to add the number of elements in the next interval. So 19 plus 10 will give me 29. Now remember, we're looking for the 25th. Where's it got to be? It's got to be somewhere in the class interval from 11 to 15. Anybody not sure how we got that? There was only 19 elements for the sum of the first 2 class sets, but there was 29 by the time I added the number of elements in 11 to 15, and we're looking for the 25th. So whatever it is, it's got to be there. Okay. All right, well, let's see what else we got here. Method of finding the median of group continuous data. Okay, so it says create a cumulative frequency curve of the data, what we were just looking at. Find the 50th percentile. Okay, create a cumulative frequency curve of the above scored data and find the median. Okay, so first, create a cumulative frequency curve. How did we do this the other day? How did we get the ordered pairs that I would plot here? Okay, so Stephanie, walk me through that again. You said the second part of the what? So the upper value of the interval. Okay, so I see what you're saying now. Okay. And then you plot that against what? Okay, the cumulative frequency. Now you'll notice we don't have a column here for that, so I'll go ahead and add it on here. Cumulative frequency, just at the very end. Okay, so we start with the first frequency, 7. In fact, we already had the first ones done. Plus 12 gave me 19. Plus 10 gave me 29. Plus 10? 39. And then we should get plus 11, 50. Remember, by the time you get to the end of that cumulative frequency column, should it match the number of elements you have? Yeah, remember we said there was 50 when we added up the frequencies. So for example, Stephanie's absolutely correct. She says we're going to go ahead and take the upper value of each class interval and we're going to plot them against the cumulative frequency. So like the first ordered pair would be what? 5, 7. We got the 5 and then we got the 7. Okay. And then what would the next ordered pair be? 10, 19. Okay. All right. So I'm going to go ahead, let you guys do that. Okay. Go ahead and plot your points, draw your curve. Now remember, there's a difference. Might as well talk about the vocabulary. Let's say I'm just making up these points right here. Okay. If you connect them with a smooth curve, remember that was a cumulative frequency curve. What if I connected them with straight segments? Remember that was an ogive. There's no one saying, I mean, you can't use one or the other. If you actually prefer the ogive, the straight segments, please feel free to use so. I'm just going to go ahead and use the cumulative frequency. if I can get this erased. There we go. Okay. All right. So I'm going to work on this while you guys are doing the same thing. So we need to get all the way up to 25. So 5, 10, 15, 20, 25. And then we got to get all the way up to 50, I believe, because that's the frequency. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Perfect. Okay. And let's see. We'll do this in a different color. Okay, so is that looking right? Okay. So the 5 ordered pairs I got from the above data, we got the first one 5, 7, 10, 19, 15, 29, 20, 39, and then we finish up 25, 50. All right. So let me go ahead. Let's use a nice green. There we go. Okay. Would everybody agree with what I have? Anybody who's not sure how I did that? Okay, now find the 50th percentile. So that means find the one element in the data that if I were to put them in order, including that element, everything below, that would represent what? 50% of the data. Okay, well, what number am I going to find over here vertically? Yeah, 25, because remember, we're taking 50% of 50. 50% of 50, so we're looking at 25. All right, let me get myself another color over here. Okay, so here's 25 right here. Hitting that, I'm going to go straight down. So it looks to me like it's going to be somewhere between 10 and 15. In fact, according to this, I could probably be a little more accurate and say what? Okay. I'd say maybe about 12. What'd you say? Okay, maybe about 12. And remember, is there going to be a leeway? Like if you don't get the exact answer I do, will it be counted wrong? I mean, probably. Yeah, I'm kidding, right? There's going to be a leeway. Okay. It's like it's what I prefer to call in the neighborhood, the ballpark. Okay. And in fact, you remember what we said a second ago? When we had just the table, we went ahead and found the median had to be between what? The middle value of the 25th had to be between 11 and 15. And does this graph kind of confirm that? Yeah. It's on the lower end of it, but it looks like we are correct. We're definitely about where we need to be. Okay, questions. Anybody having trouble? Mean, median, and mode, cumulative frequency, anything? Because I believe that's the end of the lesson, right? Yep, and then you have your assignment. Okay. So when's the homework due? Homework's due on Wednesday. Now remember, it's not taken for a grade, but if you want to retake, say, the in-class assignment for tomorrow, or even the test on Thursday, I'm sure everybody's going to pass. Remember, you have to have the homework done as part of that. Okay, good. Then what I'm going to do in the last 9 minutes, I'm going to go ahead and pass back your quizzes. And I just remembered that I probably should have gotten the folks who missed the quiz on Friday to go ahead and take it. Dadgum. How about this? How about I hold off on passing those back? Just because I have several people. If you're able to come in tomorrow morning, that'd be great. If not, I'll go ahead and have you do it during class tomorrow. Now remember, we're going to go ahead and at the very beginning do the cumulative frequency, and then if you don't come in the morning, then I'll go ahead and put you out in the hallway to take the quiz, because then we're going to go ahead and start the next lesson, standard deviation. Okay? So everybody's good with that? All right, so let's go ahead and do that.